Alright class, this is the first video lesson that we're going to do. Hopefully we'll get to do some more of these. This is done so that your homework becomes a little less and that you have more time to do work in class and possibly do more group work as we move on. Alright, so for today we're going to be taking notes over section 11.1, and what we're dealing with today is something called square roots and irrational numbers. So hopefully you guys remember some things about square roots. I don't think we've gone over it too much this year or at all, but you should have gone over it a little bit in the elementary. So let's just jump right in. So the first half, square roots. What is a square root? Well, this is a square root. At least this is a square root symbol. This is what it looks like. It's almost like a little bleep on the heart monitor. You're just going beep, boop, and then dead. Beep. Yeah. Now this by itself is nothing. We have to add a number to it. So we're going to start off with 4. You read this as the square root of 4. Okay? So that when you see this, you don't need to be in class going the little blip, the squiggly line, that thingy. No. You need to say the square root of 4. Okay? Now, what we're told to do is we're told to simplify the square root of 4. To simplify the square root of 4, you just ask yourself a very simple question. What number times itself equals 4? What number, if I multiplied it by itself, would give me 4? Well, that would be 2, because 2 times 2 equals 4. Follow along so far? Let's do a few more examples, just in case anyone's a little confused on what this is. Let's take the square root of 25. What number times itself is equal to 25? Well, that's really simple. That would be 5. Okay? Let's do a number that's a little bit larger than these ones. Let's try the square root of 121. Oh dear, square root of that. What times itself would equal 121? Might take a little thinking. In case any of you can't get it right off, here's what it would be. It would be 11. 11 times itself equals 121. So now if you're kind of wondering what the purpose of taking the square root is, it has a lot of uses, but one of the uses is that it's one of those things that's used to undo something. It's like how you can add 5 to something. So you could add 5 and then subtract 5. We've been over this class. These two actions cancel each other out. The same thing if I decide to multiply something by 2 and then divide by 2. Those two actions would cancel each other out. Okay? So the square root cancels something out. It's the opposite of squaring. So for instance, let's just look at it like this. If I have 2 squared, I get 4. If I have 5 squared, I get 25. If I have 11 squared, I get 121. They're the opposite of each other. Do y'all see that? I sure hope you do. So squaring and square rooting are the opposite. Alright, let's go over a few more things. Let's say you have a negative square root of something. Like let's say negative square root of 9. Okay? It's real simple. It's no more complicated than this. That is equal to negative 3. The square root of 9 is 3. So the negative square root of 9 is negative 3. The negative symbol basically just comes along with it, because it's on the outside, so it just comes along like whee, and there it goes. Okay? Do one more. The square root of, the negative square root of 64. That's equal to negative what? Square root of 64 is 8. So negative 8 would be our answer. Okay, so that pretty much takes care of our square roots, at least our basic ones. So far, all we've been using are what is known as perfect squares. Okay? Perfect squares are real easy to find, and they're real easy to simplify. If you're wondering what a perfect square is, basically just do this. Take 1 and square it, and then take 2, square it, and so forth and so on. Go as far up as you want. But if I take 1 and square it, I get 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. Then you would have 25, 36, 49, 64, 81, 100. You would have, how far are we going to go? So we're just going to stop there. This is 1 from 11. All the perfect squares from 1 to 11. They keep going. You can go to 12. You could even say, what's 28 times 28? That number would also be a perfect square. But we're going to stop here for now. No point in going too far. So all these are perfect squares. If I were to take the square root of any of these numbers here, it would come out nice and neat. I would have a whole number as my answer. The problem is we're not always asked to take the square root of the nice answer numbers. Sometimes we're going to be given numbers like, well, like this. You're going to be told to take the square root of 24. Well, okay. What is the square root of 24? Well, what times itself equals 24? Anybody want to take a guess? Well, since I'm a video, I can't really hear you. But if you were going to take a guess that it must be somewhere between, what numbers must it be between? Well, if 24 is between 16 and 25, what we need to do is we need to ask ourselves, what's the square root of 16? What's the square root of 25? The square root of 16 is 4. The square root of 25 is 5. So this number should be somewhere between 4 and 5. So it's going to be 4 point some decimal. Okay, it's going to have some decimal, long decimal. But it doesn't really help us to get the answer here. We can't just put down 4 and some decimal. No. But when you see these in this section, you're going to be told to estimate the answer to the nearest integer. Estimate to the nearest integer. Remember, integers are whole numbers and their opposites, meaning that you can have positive or negative numbers. That's all it means. So don't get confused by the word integer. It's a word that we've had back in like chapter 1. So hopefully you remember it. So the square root of this, what we do is we're going to put this symbol. This means we're estimating. This does not mean that it's equal exactly to, but it's that squiggly. It's like someone came and made a squiggly line or had a shaky hand when they were trying to write an equal sign. That squiggly line means we're estimating. And we're going to say, well, what's it closer to? I say it's closer to 25. So that means that it's about 5. Here's why you do that. Find out which perfect square it's closer to, and then square that. and that's going to be what your answer is. So just to see another example, let's do those real quickly. Square root of 50. What's that closer to? It's closer to 49. So we'd say, well, that's about, square root of 49 is 7. So the square root of 50 is about 7. Okay? What about the square root of, let's say 90. Square root of 90. Well, what's it closer to? Is it closer to 81 or is it closer to 100? It's a little closer to 81. It's just 9 numbers away from 81. It's 10 numbers away from 100. So we're going to say that it's about, well, what's the square root of 81? It's 9. So this is about 9. If you were to take the square root of this, you would get 9 point some numbers. Okay? So that pretty much covers us for those numbers. Okay? Now before we move on at all, I want to give you guys, this is a version of Quick Check. Okay? What I'm going to do is I'm going to write down the numbers, and then you're going to pause the video, and then you're going to solve, and then I'm going to put the correct answers up here, okay? So here's how it's going to work. I'm going to put some numbers down, you hit pause, solve the quick checks, hit play, and see if you got the quick checks right, okay? So the quick checks that I want you to try out for yourself are these. I want you to tell me what the square root of 100 is. That's the first one. That's our A. Our B is, I want you to tell me what the square root of the negative square root of 16 is. And then for C, I want you to estimate to the nearest integer what would the square root of 27 be? What would that be? Okay? So, videos will be paused right now. You're going to take a moment to answer these, and then hit play once you're done. Alright, let's see if you got the right answers. The answer for A would be 10, because 10 times 10 equals 100. The answer for this one, because it's negative, would be negative 4, because 4 times 4 is 16, and the negative symbol comes with it. And this one, it's not a perfect square. You were told to estimate to the nearest integer. What's the nearest perfect square it's close to? Well, that would be 25. What's the square root of 25? 5. So the answer for this is about 5. All right? So you would say about 5 is the answer. Let's make that a little more space. That's a little too close right there. So about 5. Now, so just so you know, you can use the squiggly marks, meaning you're estimating, or you can write your answer with words saying about 5. And that lets anyone reading your work know that this is an estimation. This is not an exact number. So that's what you can do. All right, let's move on to irrational numbers. I want you to make a list in your notes of irrational numbers and rational numbers. So we have irrational numbers and rational numbers, okay? Voila. Let's take care of rational numbers first, because they're actually numbers that, whether you guys know it or not, we've seen them a lot. A rational number is any number that can be written as a fraction. So that means any whole number is a rational number. How do you write a whole number as a fraction? Remember, class, you just put it over 1. We've done that a lot with slope recently. That means any fraction is also a rational number. It's already written as a fraction, so we're good there. Now decimals. There's a few special cases with them. If you have a decimal like 0.5, that is a rational number because remember, you can write it as 5/10. Not going to go back and explain all those rules, but you guys should remember how to write decimals as fractions. We've done that before. If you don't remember, you had better go back and review over that material. So you can write decimals as fractions. There's only two special cases though. They have to either terminate, meaning they come to an end, means they stop, like that. Or they repeat, and they can be written with a repeat bar, like 3 repeating. I know you might not remember right now, but we were able to write that as a fraction. You were able to put that as 3/9, which in case you were wondering, that is equal to 1/3. So those you're able to write as rational numbers. All of that is kind of old news review, guys. You should hopefully remember this. If you don't, like I said, you got some issues and you're going to need to go back and review over some chapters. Irrational numbers now. What are those numbers? They're numbers that have decimals that never end and they never repeat. Let that sink in for a second. That means they just keep going. You won't find a pattern in them that repeats itself where you can actually like cut and paste it over and over again to get that number, like you could with 3. I could take 3, cut and paste 3, 3, 3, 3, 3, 3, 3, and I would get that number. Irrational numbers are like, well, they look like this. You could have
2.837258721, and it just keeps going. Okay, and you don't see at any point where it stops to repeat. It just keeps going and going forever. There's a number that's like that we've actually used in math before. I don't think we've really used it this year that much or at all, but you use it down in elementary, and it's pi. Pi is irrational because it's equal to 3.14, and if you don't remember, it's got a whole bunch of numbers afterwards. It never ends. It keeps going. You can't, if you were told to count or list all the numbers of pi, you would be here for the rest of your life listing out the numbers, and no one wants to do that. So we're just gonna move on to the next irrational number. Other irrational numbers are like this: the square root of 24. The square root of 24 is irrational. If you were to type it in a calculator, like do it right here, voila, magic calculator appear. We typed it in, and oops, I forgot, it's already there. Already have it right there. So, square root of 24 is equal to 4.898979486, and the calculator decides to stop counting, but this does keep going forever. Okay, so this is a rational number if it's not a perfect square. If it is a perfect square, like for instance the square root, put it down here, the square root of 25, that's a rational number because that's equal to what? 5. Okay? Because this is equal to 5, a whole number, and we've already been over how whole numbers can be written as fractions, that is a rational number. That guy right there is irrational. So is like the square root of 2. Square root of 2. Well, what times itself equals 2? I don't know. 1? No. 1 times 1 does not equal 2. That's going to be it's going to be 1 point some number. It's a big long decimal that never ends and never repeats. I need to go over one last special case for you. And that's this. you can have numbers that look like they have a pattern, but they technically don't have a repeatable pattern. What I mean by that is this: 1.01001, triple 0, 1, quadruple 0, 1. You kind of getting the idea? And if it does the little ellipses, it means it keeps going in the pattern you see. The problem is, this pattern doesn't repeat. You don't see 0.010101. You don't see 0.0010001. No. The zeros are increasing. There's nowhere that you can stop to put the repeat bar like we have for the 3. You can't put a repeat bar over any of this to signify what's repeating. So this is an irrational number. All right? So I think that pretty much covers it. You guys are going to have time to practice this in class and do a few examples. So hope you guys have fun and enjoy